Welcome to the 4.5 Geometry Big Ideas Math Journal, which begins on page 114. We'll be going over dilations today, which you've just seen me doing. Those are dilations. Let's get going with the vocab. A transformation in which I'm on this top one. A transformation in which a figure is enlarged or reduced with respect to a fixed point. It's always related to a point, called the center of dilation and a scale factor K. Center of dilation is used up there, a fixed point used in a dilation. The dilation again is centered at that point. Scale factor, ratio of lengths of it's got to be corresponding sides. Anytime we're doing side length ratios and similar polygons, corresponding sides of the image and the pre-image. So that's, like I mentioned here, image over pre-image. Always after over before. Enlargement, a dilation with K greater than 0. Reduction is with K between 0 and 1. There is some of this involved too. They're not talking about negatives, though there is an example with negative K's a little bit later. I got a note on that too. But the enlargement K's got to be greater than 1. The reduction K's between 0 and 1. If K equals to 1, it's staying the same size, nothing's changing. This picture looks cooler in the book. You may see me do some cooler stuff with it later. Again, they're just going through the definition here. Fixed, enlarged or reduced, fixed point called the center of dilation. We just went through all that up above. This is where they get a lot of that information. Our center is usually going to be the origin. This gets a little confusing as always here. A dilation with a center of dilation ski and scale factor K maps every point P in a figure to a P prime and so on, so that the following are true. This first one, if P is the center point C, then P equals P prime. So they're basically saying if these 2 points are the same thing, if the center of dilation and point P are the same, P and P prime are the same. That's like a point on the line of reflection that we did earlier. If P is not on the center of the image, then P prime lies on CP. So they're just saying, hey, if I draw this line in P prime, you also notice it's Q and Q prime, R prime, all those lines that works on. They just mention it with the one letter here. And when we do that, we get our scale factor. Notice the center of dilation to P prime. And we can get this from some other things too. I should mention too. This is also going to be like R prime, Q prime over RQ. So there's different ways to get this. You know, P prime, Q prime over PQ. I could have done this with PR too. But those are all places you can get the scale factor. Angle measures are preserved. I do this here, just plug these in. CP is 24, C prime is 16, so that's going to be 16 over 24. That reduces to 2/3. That's a reduction. It's between 0 and 1, just like we mentioned right there. So that's a reduction. This is the rule we've been using on IXL. Again, I like to line up the points, though you can do most of this mentally. You are going to have to line up some information on the final test project. Okay, so let's go through some problems here. Find the scale factor of the dilation, tell whether it's a reduction or enlargement. So again, I got to go C to P prime over CP. Again, there's other ways to do this. 25 to 20. So I've got 25 to 20, which gives me 5/4. That is an enlargement because it's bigger than 1. Yeah. Okay. This one is just writing out the rules. So this is going to be, we've got k equal 2. I got my points. I've already graphed my first one, a prime. So that's going to be 2 times -3. And that's going to be 2, yeah, right much. 2 times 1, which gives me a prime, -6, 2. And I'm going to go plot that, -6, 2. And there's my a prime. You can do this in your head. You can do it in your head. -4 times 2, that's -8. -1 times 2, that's -2. So b prime, -8, -2. That goes right there. Should label that b prime. C prime, again, 2 times -2, that's -4. -2, 2y, 2 times -1. That's right there. That's my C prime. There's my new triangle on there. And again, notice like they were saying here, I'll even use these mega straight lines. So I line this, except it's not working out real good. Let's try this. Okay, this, I got an option on here that's not working really well. Let's just get rid of this. But if I draw lines that go through these points, whoops, I missed a little bit. It'll go through the origin. I turn my line a little bit again. Hard to draw a straight line on this. I can do it for the B's. I can do it for the C's. You can see those are all converging right about the origin. And I kind of skipped over it somewhere up here. This looks like shadow figures a little bit. Like when you're making the little dog ears on the projector. Okie dokie, you get to do number 5. Notice they give you an easy number to work with. It's a fraction, but it reduces with everything. Same thing down here. Just put it in. You can do these mentally. They gave us -0.25. Well, I know that is 1/4. It's easier to see this as 1/4. Jesus, -1/4 of 8, that's -2. -1/4 of 4 is 1. Negative times negative is positive. This is going to be -1/4 of 20 I got in there. That's going to be -5. -1/4 of -8 is going to be +2. Yeah, just checking those out. Again, you can do a lot of this mentally. This is going to be 16, -1/4 times 16, that's going to be -4. -1/4 times 4, that's going to be -1. -1/4 is 0, 0, of course. -1/4 of 12 is going to be -3, and I got my points. And sorry, I keep forgetting to put keys on these. Can't do much with the graphing ones. I can go over these in class if you want me to. Just ask. It's not a big deal. But I keep forgetting to put the keys on these. This one wasn't ready ahead of time. Number 8, use a little bit of number sense here, thinking about it to check your answer. I'm going from 8x5 to 11. It's going to be printed on 34x44. Geez, is that an enlargement or a reduction? Make sure your K matches that. Geez, it's an enlargement. It's getting bigger. Your K should be bigger than 1. If you don't get one that's bigger than 1, you made a mistake. Just remember, this is image over pre-image. Image is after, pre-image is before. You can use these two numbers because you got to do the corresponding, or those two. Whichever is going to be easier. I think one looks easier. I can use both, but... Number 9. This one, you're just going to think your image size is equal to the pre-image times K. That's just sort of that XY into, KX, KY that we were using. X goes into KX. Or, I shouldn't say that. This is the image here, so your image is equal to K times X. Just plug in your numbers. The book shows an image, G's. That's my image. Well, that's not my image, that's my K. So that's my K. The image is actually 8 centimeters. Plug those in. So the image is 8 centimeters, plug them in, and you're going to get what your pre-image was. So you're going to get something like 8 equals X times 10. Divide, and you've got your pre-image. That's it for today, kids. Hey, this one was under 15. Good for me.